Hi there, welcome to my course. In this lecture, you will learn about writing secure Android applications. SQL injection. Content provides making use of SQLite in their implementation may be prone to SQL injection attacks if user input is directly used inside a SQL statement. This may be because a developer has used the raw query method from SQLite database by concatenating SQL queries directly with user input. To protect against SQL injection attacks on Android, you can use prepared statements as you would to protect inputs from web applications. The following example shows the use of a raw query with prepared statements. The database variable is of type SQLite database. This is the example. You can do this in a similar fashion using the query method where the selection can contain the questions marks and be replaced with content in select ion arcs. This is the figure. For actions other than querying, using the SQLite statement class to execute a prepared statement is possible, as shown here. Making use of prepared statements ensures that user input is properly escaped and does not become part of the SQL query itself. Directory traversal. The basics of checking whether another application is attempting a directory traversal attack against a content provider is to test the resulting folder against a known good value. This comes down to checks that a file being requested resides in an allowed folder. You accomplish this by using the get canonical path method of the file class. This translates a path into one that has the resulting dot and dot characters removed and worked into the resultant path. Perform this check and then compare it against a list of allowed files in a certain directory or against the location of the directory itself to prevent against this attack. The following code limits other applications to only reading files within the /files/directory inside your application's private data directory. This is the code. Pattern matching. When performing any pattern matching checks against a requested content URI, always be careful about the implications of using a literal pattern match in the angle bracket path space permission tag in the form of the Android issue path attribute. There may be other valid forms of the requested data that are not covered by your logic. So, rather use a check that a certain prefix is present, or if possible, create a regular expression for the comparison. Here is an example of using a prefix for the comparison and enforcement of a path permission. This is the example. Instead of the Android issue path prefix used in this example, you could use a regular expression as follows. Hi there, welcome to my course. In this lecture, you will learn about analyzing Windows Phone applications. Chambers and capabilities. The ability of an application to access functionality offered by the OS and its services such as the camera or networking, it controlled by that app's capabilities. The Windows Phone 8 security model is based on the concept of least privilege, and as such, every application on a device is running inside one of two distinct security chambers. In the Windows Phone 8 and 8.1 security architecture, the two chambers are the least privilege chamber and the trusted computing base. All applications run in the notional LPC chamber, whether they are Microsoft written services, OEM services, or just third-party store applications. Even some device drivers run in the LPC. The only code that runs in the TCB chamber are kernel components. This figure represents this chamber architecture graphically. Windows Phone 8 and 8.1 implement the principle of least privilege by quite severely restricting the freedom of applications running in the LPC by default. Stack canaries. Stack canaries, also known as stack cookies, are random values that are placed prior to critical data such as stack metadata. When the executing function returns, the value is checked to see whether it matches the expected value. If it does, the program execution continues, and if it does not, it has clearly been overwritten at some point during the function's execution, and the application terminates immediately. Stack canaries are placed between the last local stack variable and the padding that precedes the saved frame pointer. This figure demonstrates the setup. Clearly, if a stack overrun occurs, and the stack buffer's bounds are breached, the cookie value will be overwritten, and the cookie check prior to function return will inevitably result in program termination, unless the attacker was extremely lucky and managed to guess the correct cookie value. Safe structured exception handling. When Microsoft introduced stack cookie protection into its compiler in 2003, It soon became clear that the standard return address override was no longer going to be reliable as a stack overrun exploitation method. The core of the technique revolved around overwriting structured exception handling metadata and then causing an exception to be thrown. Each thread in a process has at least one SEH record on its stack. Each exception handler is represented by an exception underscore registration underscore record structure, which consisted of a next pointer and a function pointer to an exception handler. This figure represents this concept graphically. Hi there, welcome to my course. In this lecture, you will learn about attacking Windows Phone applications, identifying and capturing clear text HTTP communications. Despite the implications of using a clear text transport such as standard HTTP for sensitive data communications, many mobile apps use plain text HTTP for the majority or all of their traffic. It is still not uncommon at the time of writing for applications to perform authentication via clear text HTTP in the mobile desktop and enterprise worlds. On the code level, a Windows Phone 8.x app may use the HTTP client class to interact with a web API. For example, in a C# application, a call to a hypothetical authentication service could be comprised of the following code. This is the code. This code performs a POST request with the username and password credentials as POST parameters. Similarly, an app could be using web client, HTTP web request or another API to make its request. The URI string object is set to http://www.myapp.com/api/login, which is clearly a URL that will result in a non-SSL protected HTTP request being made. Equally, a web browser control may have been directed towards a non-HTTPS URL, that is, this is the figure. This could also be done with a web view control. To configure a Windows Phone 8.x device to push web traffic through a proxy, first configure your test laptop to be on the same wireless network as your WP device and run your HTTP proxy tool of your choice. Then go to Settings, Wi-Fi and click the name of the wireless network to which the device is connected. The screen presented will closely resemble the one as shown in this figure. To set a proxy server, switch the slider to right and type the IP address of the system where you have previously set up your proxy tool and input the appropriate port number. This is the figure. At this point, you can see all standard HTTP traffic traveling from the device in the proxy application, such as Burp Suite, capturing a request from a Samsung ATIV device to the Google search engine, as shown in this figure. If you are using the WP8 or WP8.1 emulator instead of a device, proxy settings do not need to be configured in the device. Simply configure proxy settings via Internet Explorer because the emulator honors the proxy settings of the host system. Now that clear text HTTP traffic is being routed through an intercepting proxy, a tester can examine web traffic being sent and received by the device. An app sending and receiving sensitive information, including login credentials, financial information, medical information, or personally identifiable information, is unacceptable and constitutes a serious security threat. Hi there, welcome to my course. In this lecture, you will learn about identifying Windows Phone implementation issues. HTTP cookie storage. Because web browser and web view controls provide a subset of full web browser functionality, it is unsurprising that they store cookies much like a full browser does. The majority of Windows Phone apps we reviewed that feature web browser or web view controls don't automatically attempt to clear stored cookies after use. Assuming you has file system access to a Windows Phone device, checking whether or not cookies are cleared is easy to do for any app. A web browser or web view control will automatically store cookies to the following location: c/data/users/appdata/guide/inet-cookies, where guide is the application's guide. The inet-cookies directory is hidden by default, so you should type the full path into your file manager rather than expect inet-cookies to show up in its GUI interface. This figure shows the inspection of stored cookies in the inet-cookies directory. In applications where web browser or web view controls are hosting authenticated sessions, failure to deal with cookie deletion could represent a fairly serious security issue. Unless the device in question is enterprise linked to an active SYNS instance with required device encryption enabled, any cookies stored to the inet-cookies directory are stored in the clear when the device is at rest. SQLite-based databases. The standard SQLite distribution for Windows Phone does not support cryptography out of the box, so sensitive data being stored in a SQLite database created and managed by the standard package is likely to represent a security risk. However, two fairly well used SQLite packages do support cryptography, named SQL Cipher and the SQLite encryption extension. Both of these packages require license to use and are not freeware. SEE supports AES 124, AES 256 and RC4, whereas SQL Cipher solely uses AES 256. To create a database with encryption using SQL Cipher, developers must use the set password method on their SQLite connection object, like this. When using SEE applications, specify a key using the program statement after instanting their SQLite connection object as in. This is the figure. In both use cases, if an application uses a static hard-coded password for a sensitive database, or the password is somehow derived from non-secret data, this should be considered a security issue. Of course, you should also consider sensitive data being stored without a password a bug. SQLite databases are generally stored in the app's local folder and tend to have the .db file extension. You can check databases extracted from a device for cryptography using the SQLite 3 application, using a hex editor, or by analyzing the output of the strings mydatabase.db. Hi there, welcome to my course. In this lecture you will learn about writing secure Windows Phone applications. Encrypting databases. Two database types find common uses in Windows Phone applications: Windows Phone native databases and SQLite based databases. Windows Phone local databases. Creating encrypted local databases in a Windows Phone applications is fortunately very easy. You may simply use the password property in your databases connecting string. This is the string. Developers should not, of course, hard-code the password. Secure, credential and key management principles should be adhered to. Applying database crypto in this way results in the databases being encrypted via AES 128 in CBC mode. The key used is the SHA 256 hash of the password specified in the connecting strings password property. You can also consult MSDN's Introduction to Local Databases for a general example on implementing local database storage. SQL random number generation. In the context of mobile applications, arguably the most common use case for random number generation is in the generation of crypto keys. In modern mobile computing, mobile apps often rely on data held in an app's isolated storage as being secure, and as such, recovery of this data by attackers may potentially have very serious consequences. System.random is not fit for generating cryptographically secure crypto keys. RNG crypto service provider does not have the same problems with predictability of outputted data that system.random does. Fortunately, as well, using RNG crypto service provider is straightforward. Consider the following example for generating a 256-bit crypto key. This is the example. Although the RNG crypto service provider API is significantly slower, in the context of mobile applications, generation of crypto keys and other random data is generally a rare occurrence. Hence, the cryptographic security of the outputted data versus the speed of its generation is a trade-off that is absolutely worth it for apps that need to be secure. Securing data in memory and wiping memory. When you are handling sensitive data in memory, being able to wipe the memory when it is no longer immediately needed is sometimes desirable. Having sensitive memory secured is also desirable to lessen the chances of memory analysis attacks from gaining access to sensitive data in a process's memory space. An example of such a piece of data would be a crypto key. We advise that crypto keys be wiped from memory when they are not needed. Example scenarios for when to wipe a crypto key include when the app is placed into the background, when the app's custom screen lock is applied, when the key is not needed for the time being. In such cases, overwriting all elements of the byte array holding the crypto key is recommended. For example, this is the example. Of course, most Windows Phone applications are running in runtime, and in theory, the runtime might create additional copies of any objects. So, clearing a byte array to read the process of the data should be considered a best effort attempt. Hi there, welcome to my course. In this lecture, you will learn about analyzing BlackBerry applications, apps packages and BAR files. BAR format is simply a zip file with a well-defined structure. This well-defined structure depends on the type of application, whether native, Cascades, HTML5, JavaScript or Android. For native, Cascades, HTML5 and JavaScript, this structure is as shown in this figure. For Android, the structure is this. The meta-inf directory contains a number of files containing metadata. This metadata varies, but the common files are manifest.mf, author.sf, author.ec, rdk.sf, rdf.ec, manifest.bbr. Using developer mode. Developer mode enables you to sideload apps onto the device outside of app world, which allows you to SSH into the device as devuser and run unsigned binaries. To do this, follow these steps. 1. Enable developer mode by going to Settings, Security and Privacy Developer Mode. As shown in this figure. A notification appears in the hub. 2. Generate an RSA 4096 key pair. For example, on Linux, this is the example. Run BlackBerry space connect from the SDK to transfer the public key to the device. This is the example. 4. You should see output similar to the following if the connection is successful. This is the output. 5. You can now SSH into the device using the private key as diffuser. This is the figure. Voila! You will be SSH'd in and able to run compiled binaries of your choice within the constraints of diffuser. To install apps in a non-release manner, you need a debug token. This allows you to install apps via the BlackBerry deploy tool, but only on the device to which the debug token is assigned. Note that debug tokens are valid for only 30 days by default, and thus their value in real-world deployments is limited. The BlackBerry 10 device simulator. The BlackBerry 10 device simulator design represents a departure in terms of approach when compared to BlackBerry legacy. Due to architectural differences between the device and a PC, VMware virtual machine images are used. Due to the use of virtual machine images, there are both positive and negative aspects. The primary positive is that these images are easy to investigate and get root on the platform via a number of ways. Hi there, welcome to my course. In this lecture, you will learn about attacking BlackBerry applications. Traversing trust boundaries. The trust boundary of a BlackBerry 10 app is in the first instance of the operating system user that the app runs as. It is a trust because each app is run as a separate user. To implement the sandboxing concepts discussed, a second trust boundary may then exist in devices that are configured as balance enabled. Balance devices are configured with a personal hub and an organization controlled hub that are separated from each other via a variety of access control lists at the file and network level coupled with process separation. This look like this figure. In the diagram, each app has its own private data sandbox within which to operate, but is also free from runtime modification of the executable image. The entire container communication includes another degree of separation, that is, the inter-process communication mechanisms that would be available between app 1, app 2 and app 3 within their own container are typically disabled or limited in inter-container situations. Files. Numerous file browsers are available within BlackBerry world. They provide the ability to review what files are in the shared directory, as shown in this figure. Alternatively, you can use SSH access to review the files and their contents. For files that are held in an app's private directory, you can recover anything sensitive stored by an attack. Invocation framework. The invocation framework addresses the concept of bounded and unbounded invocation. You primarily want to focus on bounded invocation because you want to target a specific application. To understand what an app's invocation framework attack surface is, you need to look in its bar descriptor.xml. Within this file, there will be angle bracket invoke target angle bracket close tags. For example, this is the example. This code snippet says that it handles file URIs that end in .monster for open requests. When attacking invocation framework clients, you will use these definitions to attack with URIs or files that are either malformed to cause undesirable behavior in the target app or to cause files or URLs to be accessed that lead to a second stage attack.